Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 10th grade topic using your factor theorem. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below. So use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we said today or even your own homework, you can always put in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I've been linking my 10th grade playlist in which I cover a lot more topics. So if you're interested in that, make sure you stay tuned. This video is only going to have 3 parts, so leave a like, smash subscribe, and let's get started. On this channel, we've covered a multitude of different ways in order for you to factor your polynomials. And it doesn't matter if you have a quadratic, you have a cubic, or even a higher power polynomial. We've talked about different ways to tackle that type of question. Some of the methods that we've covered on this channel already include using your quadratic formula to find your roots and then creating your factors that way. We've also talked about your difference of squares. So if you have a difference of squares, or simply factoring out if you have a quadratic, and it's super easy to do so. If you have a cubic polynomial, we even talked about your sums and differences of your cubics, and you can factor it that way. And of course, if you have a higher degree polynomial, you always have polynomial long division and synthetic division to fall back on. If you have a question about any of those topics, I'll either put them right up here or I should have them in the description box below. Check any of those out. And of course, if you have any questions, put it in the comment box on any particular video, and I'll like to go further into detail to kind of help you out wherever you need it. But today we're going to be talking about our factor theorem, and it's just going to be another tool in our toolbox, especially when we have a question like this, in which all we need to do is verify that something is a factor. So instead of having to factor something out, we're just trying to check, is this a factor? Trying to limit the amount of work we have to do just to get our answer. And if we have something like this, I'm going to tell you right now, the factor theorem is going to save us a lot of steps, because overall it's a very simple and easy method to use. But before we jump into actually solving this type of question, let's first talk about what is the factor theorem. So let's say we have a arbitrary or generic potential factor. We don't know if it's an actual factor. And let's just say it's x minus c, where c is going to be some constant, right? Your factor theorem is going to say that this is a factor, and let's just cross that, break that apart. This is a factor if and only if, when you plug in, let's say you have a polynomial p of x, right? If and only if polynomial p of x, when you plug in your c, you get 0. So x minus c is going to be a factor of this polynomial here, this arbitrary polynomial, if and only if, when you plug in c, your whole polynomial goes to 0. Now this may look pretty familiar because you've probably done this a ton of times by now by simply checking to see if something is a root. Remember, your roots and your factors kind of go hand in hand. You can always create a factor from your root, and you can always find your roots from your factors. You just might not have known that there's an actual name attached to what you were doing. Now this is an overly simplified generic factor, but let's say you had something that looked a little bit more complicated. So instead of an arbitrary x minus c, let's say we had an ax minus b, right? How does this change our definition or our factor theorem? If it's a factor, then it means whenever you plug in b over a, it causes the polynomial to go to 0. So if we had x minus c, you're plugging in c. But if you have ax minus b, you're going to be plugging in b over a. And that is going to be a factor only if, when you plug it in, it goes to 0. Now, where does b over a come from? This might look very familiar because this is exactly what you do when you're trying to find your root and you have a factor. You set your factor equal to 0 and you solve for x, and you're going to get this. So if you were to solve for x here, you see that you're going to have b over a. And you're just plugging in your potential root and checking if it's a root. If it's a root, this is a factor. Quite simple. That is your factor theorem. All you have to do is a simple plug and chug, and you can easily verify if something is a factor or not. So let's move on to using our factor theorem to verify that this x minus 3 is indeed a factor of this polynomial. So our question once again says verify that x minus 3 is a factor of x cubed minus 10x squared plus 21x. Now, once again, you can factor this many different ways. Notice everything here is an x. So you can factor out the x, and then you're left with a quadratic, and then you have a lot of different things you can do there. But we don't want to have to do all that work. We just want to know, is x minus 3 a factor? And the factor theorem is going to help us do that by simply having us plug in 3 into x cubed minus 10x squared plus 21x. That's all we have to do. If this goes to 0, x minus 3 is a factor by our factor theorem. So let's do that. And when we simplify this, we're going to get, and of course you have 27 minus your 90 plus 63. And when you combine all of this is going to equal what? 0. This tells us that x minus 3 is indeed a factor of x cubed minus 10x squared plus 21x. And that's because 3 is a root of this polynomial. Let's move on to another example just to get a little bit more practice using our factor theorem. Let's say we have this question here in which we want to verify that x plus 4, that is a factor of x cubed plus 4x squared minus 3x minus 12. Like, once again, you could factor this in different ways, but we don't want to have to do all that work. We just want to check, is this indeed a factor? So we're going to use our factor theorem, and we're going to plug in -4. Remember, we're going to do the opposite sign here. So if it's x plus something, we're going to have a negative of that something. If it's x minus something, we're going to have a positive of that something. So we're simply plugging in our root and checking, does it go to 0? So we're going to plug it in everywhere there's an x. So we're going to have, and when we simplify this, we're going to have, and you can see already that these are canceling out, leaving us with a big 0, which tells us that x plus 4 is indeed a factor of x cubed plus 4x squared minus 3x minus 12. If this didn't equal 0, x plus 4 would not be a factor. However, because it equals 0, our factor theorem tells us that this has to be a factor. So I hope you were able to follow along with today's video and hope you see just how simple your factor theorem really is. However, if you have any questions about what you saw today or even your homework, you can always put in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like. It surely helps the channel by letting YouTube know that you found a video helpful. And if you found a video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I really hope this helped with your homework, and looking forward to seeing you again next week. I'm Courtney, here's your playlist, and this has been another session of Tutor Me Sempai.